My name is Margot Rain. I am a member of the Adult Ed Committee here at Westminster Presbyterian Church. We apologize for the delays, but I am so happy to be here today and to welcome our guest speaker, Jim Lee. Jim is a familiar face here at Westminster. He's spoken to us on a number of topics. He is a certified futurist and has founded the investment firm Stratify. But to us here at Westminster, he is the daughter of Virginia Lee and the sister of Tara Lee. Longtime, well-loved members. Today, Jim is going to be speaking to us about transhumanism and beyond, the future of human evolution. Jim?
Great. Well, it is so nice to be back and to see people for the first time in 2 or 3 years. So thanks for having me. And today I get to talk about transhumanism, which is going to be very fun. It's very edgy stuff, so I think I may push a few buttons today. That's always interesting. And I work as a professional futurist, and my job is to sort of figure out what happens next. And we're going to go way out. We're going to go beyond decades. We're going to go beyond centuries. We're going to go into millennials of futures for us. And transhumanism is really about choosing who we wish to become, okay? And to a certain degree, that's influenced by our technology preferences. And if you go back far enough, in human civilization, we have sort of 3 different clusters of technology. You have biological technology, and in Western civilization, you could argue that the roots of our civilization is based in bread and wine, okay, which is all yeast-based, which is early biohacking for us. There's physical technology, and here we're talking about the Industrial Revolution, machinery, internal combustion engines, etc. And then more recently, you have the digital revolution, which was arguably started back in the 1950s with the release of the semiconductor. And then you have sort of where these areas intersect. Between the biological and the physical, you have what we call the real world, which I like to visit sometimes, okay? Between the physical and the digital, you have automation, okay? You have robotics. In between the biological and the digital, you have something that I refer to as the biodigital, right? And this is very, very new. I mean, Watson and Crick only discovered DNA back in the 1950s. And we only sequenced the human genome in the early 2000s. And we're beginning to see digital intelligence emulate biological life in the form of AI, or artificial intelligence. The idea here is that we may see more change and variation in the human form over the next 100 years than we've seen in the past 10,000. And that's because we adapt to our environment, okay? And as we press out into space, we will have dramatically different environments going forward, and as a result, we're going to have dramatically accelerated human evolution. Now, if you look at what's been going on recently, meaning the last 40,000 years or so, okay, we evolved vocal cords about 40,000 years ago, FOXP2 gene. And we also evolved the ability to have breakfast, okay? Adult lactose tolerance is a relatively recent change in our genetics. In the Ice Age, we developed a plant-like superpower, and that is the ability to synthesize vitamin D from sunlight. More recently, we're beginning to see within city pigeons changes in the ability to regulate blood sugar to prevent diabetes. So we've had diabetic pigeons all this time, and they're beginning to figure out how they can eat our food without getting sick. We've also had evolution. In Africa, people have evolved the ability to tolerate malaria better. Now, the fastest evolution that we've documented happened in Tibet about 2,000 years ago, and that's the ability to tolerate low oxygen environments. So there's a gene that's present in about 8% of Han Chinese and is now available in, I think it's 97% of Tibetan Chinese. to deal with, again, lower oxygen levels in the environment. This is, I think, the RPA1 gene. Now, talking about recent superhuman changes, right, mutations, this is a story in the New England Journal of Medicine that showed up a few years ago about a Connecticut man who was in a serious automobile accident. And he walked away from it almost completely unscathed, okay? He didn't have any broken bones at all, and they said, this is really odd, okay? How could this happen? They went to the hospital, and they found out that he had bone density that was 8 times greater than normal. He was literally unbreakable. And then over the years, some of his family members kept showing up in the hospital for sort of strange reasons, okay? One of them had a hip replacement done, but they couldn't screw the hips in because the screws kept breaking on his bones, okay? Another time he had a nephew or a niece come in and she had some issues because she couldn't swim because she was too heavy, because her bones were 8 times more dense than usual. So when you look at some of these mutations, for every gimme there's a gotcha, okay? Right? You know, maybe you're indestructible, but you know, your hips might have, you know, some wear and tear on them. There's another story here about athletes. Eero Montiranta, which was a Finnish cross-country skier, had about 50% more hemoglobin than usual, which is great for endurance. Dean Karnazes is around today. And he doesn't produce lactic acid. He can run around, never get sore. One time he ran 50 marathons in 50 days, and he stopped running marathons just because he got bored. He wanted to do something else, you know, and kind of proved his point. Now this little guy, Liam Hoekstra, sort of started out normal, okay, and when he was about 5 months old, you know, learning how to walk, he raised his arms up, and parents kind of would reach down and kind of help him walk. And what he did is he pulled on his parents' arms, and then he pulled himself onto an iron cross, which is a gymnastics maneuver, which takes a lot of strength. And his parents kind of knew something was up at this point. And then when he became 2, he had a temper tantrum and punched a hole in the wall, and they thought that was kind of peculiar. And as it turned out, he had a unique genetic configuration that inhibited the growth of myostatin. And myostatin, in turn, inhibits the growth of muscle. So if you inhibit the inhibitor to muscle growth, you get a lot of muscle. And in this case, this toddler had 40% more muscle than usual. But again, there are always trade-offs, okay? And the trade-off here is if you have that much more muscle, he has to eat 6 times a day. So you can be strong, but you can also be really hungry at the same time, all the time. I think now he wants to be a professional hockey player, and I think he has a good shot at that. So we now have the ability to tweak our genes very selectively, and we can do that through CRISPR. And one of the interesting things behind that is it uses a viral vector to introduce new information into our genomes, and if done early enough can also influence our germline, which has been demonstrated before. But if you look at our genetics, you have 2 combinations of base pairs, okay? You have adenine, which always shows up with thymine. You have guanine, which always shows up with cytosine. This is almost a type of binary code. It's 1s and 0s. Okay, it's the same way that we program our own computers, but this in turn programs us. What they're also finding is that genetic information is remarkably dense. It's also remarkably stable. You have more genetic information, more information in a teaspoon of DNA than you have in all of the iPhones of the world put together. It's shelf stable. It can last for thousands of years. And you know, we're beginning to write information, sometimes books, even with genetic data. Now, here's a woman in bioscience. I mean, tweaking your own genetic information is still very controversial. So she went to Mexico, and she edited her own genome using some of these techniques. And she did two things. One is she extended her telomeres by 20%. She was born with shortened telomeres, and telomeres in part determine life expectancy because your cells can only divide so many times, and with longer telomeres they can divide more times. And she also introduced a myostatin inhibitor, like that young boy a few slides ago, so that instead of becoming weaker over time, she would offset some of her muscular atrophy as she gets older. And she started doing this about 5 or 6 years ago, and she's still alive and running, and no adverse side effects. But that doesn't mean that we should all run around biohacking our own genetics for a few different reasons. And one is we know where the switches are, but we don't know what they do at this point. Okay, and there's a lot of learning that we need to do on that. Another is this issue of mosaicism, and that is that if you send out new instructions to your body, and some of your cells get the memo, and other cells don't get the memo, then they're not necessarily going to be able to agree on everything. And you see that in organizations all the time, okay? The third thing that can happen is what they refer to as off-target changes. In other words, if you reach for one switch, but you hit another switch by accident, then you have those issues as well. Now, you can talk about CRISPR technology as a type of word processing of our genetics. At the University of Delaware, they've also introduced spell check to be sure that we're not pushing the wrong buttons, as it were, on some of these genetic changes. But there's also the ability to adapt to our technology. Okay, and this one came out a few years ago in the Washington Post. It was a study done in Australia where they noticed where adolescents were growing horns out of their head. And I'm not talking horns like this, okay? I'm talking at the base of the spine. They were noticing bone spurs because they were doing this all the time. And the spurs had developed to support their heads while they were texting on their phones, okay? So again, humans are remarkably adaptable. Here's another one, Hugh Herr, who was now a professor at MIT. When he was 16-year-old, he was mountain climbing in the Alps. He tragically lost both of his legs, and he since became an expert in creating artificial limbs. And now he has multiple sets of legs, some of which he uses for mountain climbing, some of which he uses for running, some are for dancing, some are for looking like a regular person. He can be 8 foot tall one day, and he can be 6'4" the next day. He gets to choose, okay? And that is pretty fascinating stuff. There are some work being done to enhance the human exoskeleton, again, cybernetically, largely in the automotive industry, where you have people doing repetitive motions like drilling the undercarriage of a car or lifting heavy parcels. Again, you're beginning to see some of these exoskeletons be developed. And increasingly, as surgical implants, you've heard of the idea of augmented reality, where you have a lens that creates a digital overlay on top of the physical world. And that lens might become our fourth or our fifth screen. So the first screen was the movie screen. The second one was the television screen. The third one was the computer screen. The fourth one is the cell phone. The lens, as it may be called, could become our fifth screen and internalized. Here we go. Cybernetics is already here today in that we have cochlear and retinal implants. And Facebook is now teaming up with Ray-Ban to create smart augmented reality glasses. In fact, they renamed their company as the Meta Company a month or two ago. And this gets kind of scary, okay? So this is the US military's cyborg soldier 2050 human-machine fusion project. They've sort of outlined some of the capabilities that they see happening potentially by 2050. They talk about ocular enhancements to be able to see infrared and at dark and see through walls, programmed muscle controls through optogenetic bodysuit sensors, the ability to have super hearing, and then direct neural enhancement of the human brain for two-way data transfer. What could possibly go wrong with that? Okay, I mean, yeah, sure. So DARPA, Department of Defense research program, is now working on self-contained neural implants that can use to produce internal painkillers, for example. And if you're a soldier in battle, not feeling pain could be helpful. Transcranial magnetic stimulation as a way of improving human cognitive performance. And then, of course, Facebook again, buying control labs for its mind-reading wristband. It's pretty clear they want to get in your head, okay? Better ads that way. As I started looking into the mind-machine interface, it first sort of seemed a little science fictional, but I was surprised at how many people are working on this technology and how many different flavors it's coming in, okay? I mean, you have neural dust, which you sort of sprinkle inside your head. You have neural silk, which is a wrap that you can put over the cranium. You have neural stents, neural meshes. Pretty much everyone's working on this technology at this point. The original idea came from an Ian Banks novel that was written about 20 years ago. I think that what we're doing in terms of reading the mind using electrical impulses and using magnetic impulses is probably early. Ultimately, I think that the mind is probably an optical signal receiver. So they talk about optogenetics, which is about hacking the genetics to make the brain more sensitive to certain types of light, to send signals a little bit more quickly. And this leads to this whole digital immersion or mind-machine interface where we can all eventually, possibly, be hooked up to the internet all the time. We can fact-check each other really quickly that way. So Elon Musk says, I hope we're not the biological bootloader for digital superintelligence. He feels, unfortunately, that's increasingly possible. Neil deGrasse Tyson says, would it be cool if our lives, our planet, our solar system, our universe were part of this big data simulation conducted by aliens? Many different varieties of that. This was a study that was done by Pew Research Center a few years ago about whether people are enthusiastic or worried about some of these emerging technologies. The first technology, gene editing, giving babies a much reduced disease risk. And more people were worried than enthusiastic about that. The second one was for a brain chip implant for much improved cognitive abilities. A lot more people were worried about that one. About 70% were worried, about 30% were enthused. And then synthetic blood for much improved physical abilities. Maybe go swimming underwater for 15 minutes or half an hour without breathing, that kind of thing. Still highly controversial stuff. So, I'm not quite sure how ready we are for this. But people change. You think about the 1970s when in vitro fertilization came out. That was fairly controversial stuff. We called them test tube babies at the time, and now a lot of people go for IVF treatments, and it's not a big deal. So there's another type of evolution which I'd like to touch upon, and that's this idea of spiritual evolution. And this is a quote from one of my favorite philosophers, Pierre Teilhard de Chardin. He was a French theologian, anthropologist, and futurist. And he asked, suggested, we are not human beings having a spiritual experience, but we're spiritual beings having a human experience. And he writes about sort of a universal or a global consciousness referred to as the noosphere. And he was writing this well before the internet. He was talking about this in the 1920s and the 1930s, felt that the Earth had a layer of information that we could all access. And for him, really spiritual evolution is moving beyond physical consciousness, moving beyond mental consciousness, moving towards this global consciousness. And it goes under a bunch of different names, okay? Whether you're looking at the Akasha, which comes out of the Sanskrit Hindu tradition, whether you're looking at the field of Erwin Laszlo, the Implicate Order by David Bohm, who is a friend of Albert Einstein's, or Rupert Sheldrake's morphogenic field. And it all sort of ties into this idea of not the internet of computers, not the internet of things, but really sort of the internet of life. Is there a way in which we can all be connected and all be able to relate to each other? And there's some evidence, anecdotal evidence, that this could be a thing. One example comes if you do the New York Times crosswords. And they find out that the first day that the crossword puzzles come out, it takes everyone longer than if someone does the crossword puzzles a day after everyone else does them, okay? And they're not comparing notes. It's just a little easier after other people have solved that problem. There's also something called the Flynn Effect, and they started noticing this back in the 1960s because they had to recalibrate IQ tests every 10 years, okay? So every 10 years, the students were getting IQ scores about 2 points higher than they were the decade previously, okay? So in some ways, they're all becoming smarter. And if you have an IQ test, this is a problem because average is supposed to be 100, proving that all of our children, of course, are a little bit above average, okay? So there you have it. And then you also have sort of this issue of simultaneous inventions, where multiple people are having the same breakthroughs at the same time. It's like the ideas are coming from somewhere else, whether it's for calculus, vaccination, or for the telephones. I find that just super interesting. So there may be a structure that enables us to connect on this level. And this one came out in PubMed a few years ago, where they've discovered calcite microcrystals in the pineal gland of the human brain. Really edgy science here, but the pineal gland is considered to be the seat of intuition in Eastern philosophy. And in my parents' house, crystals were used to power radios, okay? So radios convert light signals into sound signals. And maybe we have that ability internally. I don't really know, but I find that very intriguing. So, if we can evolve our consciousness, and if we sort of adapt what can be thought of as spiritual technologies, sort of soft technologies versus hard technologies, right? Greg Braden asks about what we can reasonably accomplish in our lifetimes. And one is wisdom, okay, which comes from getting the insight of the experience of others. The second is empathy, which is sort of early stage telepathy. It's being able to feel what other people are feeling and to relate to their circumstances. And the third one is longevity. And I was doing another talk on human life extension. Ran into a book called The Blue Zones of Happiness. And they talked about how a lot of communities that have extraordinary life expectancies have a few things in common. One is a plant-based diet. 2, they tend to be very physically active. And 3, they're all engaged in some type of spiritual community. It doesn't seem to matter which one. So these, I think, are some of the benefits of this fourth technology that sometimes we overlook, and that is, again, spiritual evolution. If enough of us do this at the same time, we may be able to evolve from a culture that's based primarily on intelligence, okay, to wisdom. And intelligence is about having more, and wisdom is about having enough. Healthcare goes from living long to living well. You go from competition to cooperation. You go from trying to get the right answers to simply asking the right questions. And the outcomes, instead of getting something right, getting everything kind of right, or at least a little bit better. So I think that's an alternate path of evolution for all of us. So those are some disclosures to keep my compliance department happy. I think, we have some time for questions. If I've stirred things up for you, I'm happy to chat. So, thank you.
Does anyone have questions?
The level of consciousness that you just had up, is there somewhere we could get a copy of that?
Wow. You mean Teilhard's work?
The one that the last slide. What, I need to have it.
Oh, I just made that up.
You made that up?
Yeah, I did. So the only place where you'll actually find that is in a book that I put out last spring. It's called Foresight Investing, A Complete Guide to Finding Your Next Great Trade. That was my COVID project, was finishing that book, And I talk about long-term social change, and it's a part of that. I think this is what could be referred to as a possible future. I don't know if it's the future, but it's not a bad one. Mm-hmm. Yeah.
Seems like our technical ability to edit the artificial intelligence is outpacing our wisdom as to the possible consequences. It seems much more complex than we can possibly figure out at this point. And I guess my question is, as you look in, I'm encouraged to hear you talking about millennia into the future, but I sometimes worry or wonder if we're not, going to sort of outpace technologically our ability to really manage these new technologies.
Yeah. And we struggle with that. And I think that's why we have a lot of controls over the use of some of these CRISPR technologies until we really have a better sense of knowing what we're doing. And I think one of the themes of the talk that I have today is really this idea that there are always trade-offs. And there's a matter of, are the trade-offs worth it or not? Okay? You can be 40% stronger, but if you have to have 6 meals a day, I don't think the planet can necessarily support that. If you look at the adaptations to malaria, okay, when you have too much of that change, you end up with sickle cell anemia, which is sort of also a problem. So it's really a matter of being adapted for the world that you live in.
Any other questions?
Yeah.
I've been reading recently about Metaverse or Meta-universe.
Yeah.
How does that fit into sort of reality, or how reality is going to change for us?
Yeah, so that's about adding another layer to the world that we live on. And Facebook kind of hijacked the term, okay? So a lot of people are upset about that. But the metaverse is really about creating an open system of virtual realities, okay? There's a movie that came out 2 or 3 years ago called Ready Player One, so that you could take items, wardrobes, resources from one virtual world, almost like a game world, and carry that into another, okay? Which will probably be enabled by the blockchain, probably be enabled by cryptocurrency. It also, to a certain degree, refers to augmented reality, which is that informational overlay that may go on top of the real world. So I talked a little bit about the lens, okay, which could be eyeglasses or they could be contact lenses. I don't know which one yet. And you could imagine going down the street and seeing reviews by Yelp on every restaurant as you walk by it. You could go to a networking event and see the names of all the people that you should probably already know, okay? You might be able to look out the window and get a weather report. So it creates an information-rich template that goes on top of the real world. And that's a part of the metaverse as well, right? So, yeah.
Yes. Has there been research done on ways to put an end to so much violence in our society, such as the gun violence?
Wow.
We know the underlying problems.
I know, and it sort of feels like we've gone a little backwards on this one over the last few years. And I think what's going on there is when I was a teenager in the 1980s, I'd go to the arcade and I'd play on an arcade machine. I'd, hit the buttons repeatedly, and that was fun. And then 40 years later, the machines are kind of playing us, and they figured out where our buttons are, and they, hit our buttons, and that's fun for the machines, okay? so that's sort of where we are at this point. I think, again, that sort of the spiritual technologies, personal consciousness, understanding the impact that you have on the people around you and on your community is really going to be the solution for that. It's not going to be playing more or fewer video games. It's connecting with people on a different level. Yeah. Oh, yeah. Mm-hmm.
In one of the articles that I read early on with COVID was they were saying we've probably jumped 10 years in that 1 year in terms of our use of digital technology. Mm-hmm. And that we certainly are experiencing that as a church, as most churches are. I just wonder what you might be seeing as we continue to look at the future of church. What is showing up in terms of what you're seeing and reading and as the future of church? Maybe technology-oriented, certainly I'm thinking conscious and wisdom-oriented, but how will we continue?
Yeah, well, I think that there's a real thirst for community right now, okay? Mm-hmm. And that people find out if you disconnect people from other people, we all go a little crazy. And we're kind of miserable at the same time, So I think that you are going to see a pickup in interest in live physical events, in the arts, in music, and you have, a lot of that within a church experience. So I actually feel that we're at a bit of a low point right now, and there is potential to pick that up as well as people seek to reconnect.
And change.
And change, yeah. So yeah, you have more types of platforms, and you also have people wishing to connect from many other places. So I've seen this idea of sort of the global nomads picking up a lot. I've had clients now working from Washington State, Costa Rica. I have a client retiring in Italy. I have some in Malaysia. people can live anywhere they want to live, and they can selectively connect with any community that they want to be a part of. And that really has accelerated quite a bit.
Yeah, the whole definition of community has changed.
Yeah, yeah. It's almost less a matter of where you're born or to who you're born to and to who you choose to affiliate with. So I think really the vanguard of transhumanism comes within the transgendered community, okay, where they were born one way and they choose to live or express themselves another way. And that can be a really tough transition, but they're doing it. And I think it's interesting.
I don't think that's exactly how they would say it. They were named one way. They weren't born one. They're the same person
fair enough.
they were
Yeah,
when they were born. They were just experienced or seen differently.
Yeah.
Yeah, and had to work against that.
Yeah.
Yeah, and you're right. I think that is challenging us all.
You choose to be who you are.
Yeah.
Mm-hmm. Yeah.
So, not that I understand exactly what an NFT is,
Mm-hmm.
but I'll throw it out. So, help me understand sort of the evolution of value in the digital world, because, like, I guess Jack Dorsey's first tweet generated a lot of revenue. So I'm just trying to understand this notion of value that's not concrete, that's different. So I was just curious about your thoughts on that.
Yeah. I might be back this fall to talk about that.
Oh, okay.
You know, what's going on in cryptocurrency. And really, NFTs create what are called digital twins, okay? Digital twin. And non-fungible token is a token of a digital artifact that is not like any other tokens available. And what happens is when ownership of a digital asset becomes a right to a physical thing, that's when things get really interesting. Okay. And that is NFT. It's the digital certificate of ownership. And people are just trading those right now. And I like to say that every tool starts out as a toy, and NFTs are the sandbox right now, okay? And that's what we're playing around with, and we're figuring out what they do, but it's still super early. Where we are right now with NFTs and cryptocurrencies in terms of adoption is exactly where we were in 1998 with the internet, okay? So as many people today have some cryptocurrencies as had email addresses in 1998. Still super early, okay? The killer app for the internet was email. You know, that's why we all got on the internet. The killer app for cryptocurrency is sending value. So that's a really big topic, and maybe I get to talk about that in a few months. Yeah, cool.
Well, thank you, Jim. This was really interesting and enlightening, and we do hope to have Jim back in the fall talking about cryptocurrency, so keep an eye out for that. But this has been recorded, so I'm assuming it will be on our website at some point. Okay, thank you.
Okay. Thanks.